So this next example is used for modelling discrete distributions or discrete situations in a normal distribution. So we're talking about IQ tests, an integer score. Now the key word there is the integer score. When you look at a normal distribution, no, I need to get one out of. When you're looking at a normal distribution, Blue Peter, you end up having a nice smooth curve. Now a normal distribution applies to continuous variables, and since it's an integer score, this is a discrete variable. So if I was to take, for example, the value, let's pick a number, 106, there we go. So if I was to take the value 106 and I assume, from my own knowledge, the means on IQs is always 100, that 106 is part of a continuous distribution, but we've got an integer score. So what will actually happen, and obviously I'm making it a bit bigger than need be, is I'm going to need to take every value from 105.5 through to 106.5, and that will make up the specific score that I have at 106. So if you go to an IQ of 106, you're actually in between this area. Now this particular thing is continuity correction. You're correcting for the fact that you've got a discrete value and you're using a continuous distribution to model it. It generally happens when you use the normal distribution to model for the Poisson or the binomial, which you'll do in the next section anyway. So for this particular question, I can now no longer look at, for example, 106 to 110. So in the previous examples, what I'll have done is I'll have said, all right, let's have a look, and we shall go from the value of 106 all the way through to 110. However, this actually won't include everything that I need, because what I'll be missing off is just at the very edge, I'll miss off this section, which actually comes from 105.5, which will round to 106, and I'll be missing off this section, which is 110.5, which will actually round to 110. Now, we're talking boundaries here, so I'm not worried that 110.5 rounds up to 111. This is our upper limit. So we're looking at bounds from GCSE. So actually, for my diagram, what I'm going to have, hang on, takes a long time to get rid of it. So what I'm going to have now, if I actually do this question, is I'm going to be looking for, specifically for me, IQ tests, so pen, mean of 100, standard deviation in this IQ test was 15, so standard deviation of 15, and I want to find 105.5 to 110.5, I want to find this area here. And then we're just back into the stuff that we're doing in the last few examples. So we find our standardized scores, so 105.5 minus 100 over 15, and that will give me my first standardized score, which I'll put in here. My second standardized score will be 110.5 minus 100 over 15, and that will give me Z2, which I'll put correspondingly with that. So I'll just work those out. There we go. So what I'm actually going to do to find this area is I'm going to do phi of this score, which is 0. Where am I? Oh, I've put them the wrong way. So phi of 0.7, which is all of that from 110 all the way down. I'll do it in purple actually. All the way down there. That's phi of 1.7. Then I'm going to minus the bit in yellow, which is all of that, and that should give me my final answer. So I'm going to minus phi of, where are we, 0.3667. So for that I'm going to need my tables. So here are my tables, which I'll just tidy up. So phi of 0.7 exactly, that's there and there, so it's 7580. So 0.7580 minus 3667, so phi of 0.36, and then I can really only do 6 and another 7 there. So the 6, 0.3 6, 6, and the 7 will be in between there. It'll be about 2/3 of the way through. So we are on these two, 2/3 of the way through. That's going to be 2.5. So 0.6406 plus 0.0025. So I get a value of 6431. So minus 0.6431. That wasn't necessarily exact. Trying to do those bits. If you can't do those, use a bit of common sense. It's 2/3 of the way through the next tenth. So if you can get 2/3 of the way through your point, then that's what I've done. So I've gone 2/3 of the way through that gap. I've done it in my head, so it might not be perfect. Some of you will have calculators which will actually be able to do this particular function on it. If in doubt, ask your teacher. So what's that? 7580 minus 6431, obviously 0 points at the start, so that's 0.1149. And so that should be my answer. So, I've forgotten the question now. A large number of people have their IQs tested. What proportion of them would you expect to have? Well, I'd expect 11.5% really to have their IQs between 106 and 110.